Security basics for programmers. Beginner level. Introduction. Modern software systems handle sensitive information, such as user passwords, personal data, payment information, API keys. If applications are not designed securely, attackers may steal data, damage systems, or gain unauthorized access. Because of this, developers must understand basic security principles while writing code. Security is important for web applications, mobile apps, APIs, cloud services, databases. Learning security basics helps programmers build safe and reliable software. What is software security? Software security refers to the practice of protecting applications and data from attacks, unauthorized access, and vulnerabilities. In simple words, software security equals writing code that prevents attackers from exploiting the system. Security must be considered throughout the entire development process. Why security is important? Poor security can lead to serious problems such as cross-mark data breaches, cross-mark identity theft, cross-mark financial loss, cross-mark system compromise, cross-mark loss of user trust. Many real-world cyber attacks occur because of simple programming mistakes. Common security principles. Programmers should follow several basic security principles. 1. Authentication. Authentication verifies who a user is. Examples: username and password, multi-factor authentication, biometric login. Example: login flow. User means login credentials means server means verify identity. 2. Authorization. Authorization determines what a user is allowed to access. Example: admin users can delete data. Regular users can only view data. Example: flow. User authenticated means check permissions means allow, deny access. 3. Data encryption. Sensitive data should be encrypted so attackers cannot read it. Example: encryption use cases: HTTPS websites, encrypted passwords, secure messaging apps. Example: plain text means encryption means encrypted data. Only authorized systems can decrypt the data. 4. Input validation. Applications must verify user input before processing it. Example: problem. If input is not validated, attackers may inject malicious code. Example: attack. OR1 equals 1. This could bypass login systems. Input validation prevents these attacks. 5. Secure password storage. Passwords should never be stored as plain text. Instead, they should be hashed. Example: password means hash function means stored hash. Common hashing algorithms include bcrypt, argon2, pbkdf2. 6. Principle of least privilege. Programs should give users only the permissions they need. Example: a regular user should not access admin settings. A database service should not have unnecessary permissions. This limits damage if a system is compromised. Common security vulnerabilities. Some common programming vulnerabilities include SQL injection. Attackers manipulate database queries. Example: select asterisk from users where username equals admin or1 equals 1. Cross-site scripting. XSS. Attackers inject malicious scripts into websites. Example: alert, hacked. Cross-site request forgery. CSRF. Attackers trick users into performing actions without their knowledge. Example: unauthorized bank transfers, changing account settings. Secure coding practices. Developers can reduce security risks by following best practices. Checkmark validate all user inputs. Checkmark use HTTPS for communication. Checkmark hash passwords securely. Checkmark limit user permissions. Checkmark keep dependencies updated. Checkmark log and monitor system activity. These practices significantly improve application security. Real-life analogy. Think of security like protecting a house. You use locks on doors. Authentication. Different keys for different rooms. Authorization. Security cameras. Monitoring. Alarm systems. Intrusion detection. Similarly, software systems use multiple security mechanisms to protect data and resources. Advantages of secure programming. Secure programming helps. Checkmark protects sensitive data. Checkmark prevents cyber attacks. Checkmark maintain user trust. Checkmark ensure system stability. Checkmark comply with regulations. Security is an essential part of professional software development. Challenges in software security. Some challenges include crossmark complex systems with many components. Crossmark new vulnerabilities appearing regularly. Crossmark human errors in coding. Crossmark evolving attack techniques. Developers must continuously update and improve security practices. Where security basics are used. Security principles apply to many areas. Web development, mobile applications, cloud computing, banking systems, healthcare systems. Examples: secure login systems, protecting payment data, securing APIs, preventing unauthorized access. Simple definition: software security, the practice of designing and writing programs that protect systems and data from unauthorized access and attacks. Final summary: security is a critical responsibility for programmers. Developers must protect applications by checkmark implementing authentication and authorization, checkmark encrypting sensitive data, checkmark validating user inputs, checkmark storing passwords securely, checkmark following secure coding practices. By applying these principles, programmers can build safe, reliable, and trustworthy software systems.